Okay, so on 29, we got a plus 3 equals a squared minus 2. So can we just get a squared by itself here and then square root? No. Why not? Because we also have an a. So what we want to do is move everything to one side and either factor it or use quadratic formula. So actually, since the a squared is on the right side, I think I'm going to try moving everything to the right. Usually you want a squared to be positive. Makes it a little bit easier. So how do I move these two guys over? How do I get rid of the plus a on the side? Yeah, minus a and minus 3. Okay, so that just goes away. We get 0. That's what we want. We want one side with nothing. Now, do all these mix together? No. A squared is by itself, and then a minus a, and then these two do go together. Negative 2 minus 3 is negative 5. Alright, does that factor?
Yeah.
Do two things multiply into 5 that add up to negative 1? No. The only thing that goes into negative 5 is like negative 5 times 1. That does not add up to negative 1. So if it doesn't factor, what do we got to do?
Quadratic formula.
Doesn't factor, that means the answers are going to be weird, like square roots and stuff. So, do I remember? No, I don't.
I'll do it.
You're on Leah.
Where are we at?
You're at Leah.
You're going to be Wyatt.
Leah doesn't go to this class.
Wyatt, I didn't say you can move.
Well, there's like no room.
You can ask, and I would
John,
have
you
said
screwed
yes.
over on the side.
But you
What?
Alright, I think Case did it yesterday, so let's go. Didn't we do the front row yesterday?
Yeah.
Okay, let's go.
Except right now,
Like halfway.
Okay.
Half the line. Yeah, you're halfway through this middle row.
I said I'll do it.
And then you jump to the first.
I said I'll do it.
So you'd be at like, yeah.
Okay, so I didn't do the second row.
I'll
No.
do it.
You did
Alright,
the back end.
Bo, what's the A, B, and C on this one?
1, negative 1, negative 5.
Right. So, whoops, I don't know what I'm doing. So if I plug that in the quadratic formula, what would it be?
Be like 1 plus or minus the square root of 1 squared minus 4 times 1. And then see minus or times negative. And then over times that negative.
No, it's 2 times A, so 2 times 1. Alright, so,
would it be negative 1 squared on the inside the square root?
you could, but you'd have
It
to
doesn't
put
matter.
parentheses around it. When you square a negative, it's still positive.
Okay.
So no, it doesn't matter. It'd be easier just to call it 1 squared. Okay, so this is 1, this is minus negative 20, so it's 1 plus 20 squared root of 21. So inside the square root, does square root of 21 simplify? No, it's 21 is 3 times 7. Remember, there has to be doubles for it to simplify. So can we do anything with that? The answer is no. This is why it didn't factor, because it's a weird answer. Oh, I forgot to zoom out. No wonder it looked a little bit weird. You have to come back. We're on a time limit. Number 20 or 31. X plus 7. X squared plus 10x plus 25. What do you guys think? What should we do on this one?
Factor and then from.
Nope.
Subtract x.
Right, you wanna move everything to one side first. And then factor. Because if this is not equal to 0, then that factoring trick doesn't work, because you gotta say what makes it equal to 0. So you have to have a 0 over there. I'm gonna subtract x and 7. So that goes away. We get 0 equals that. Does that one factor? Okay, again, if you don't like factoring, what can you do? You can do this. But if you're good at factoring, it's quite a bit faster. So on this one, what multiplies into 18? Jonathan, that adds up to 9. What can multiply into 18? 6 and 3. Does that add up to 9? Yes. So it's x plus 6 times x plus 3. And then because this is equal to 0, this only works if it's a 0. What x values would make this or this equal 0? Yeah. And if you use the quadratic formula, you should get the exact same thing. Through that section. Okay, so on 33, let's see. How about, actually, let me pause for a second. What about number 30? Any ideas on that one? Well, before you do that, though, she said take stuff out, but before you do that, yeah, you need them to be on the same side before you start factoring. So, yeah, you can minus 8x. And then what could you take out? Alright, you guys remember this one? We talked about this yesterday a little bit, and that one. Two answers. That's an even. I'll let you guys try and finish it. If you have questions, you can ask. Like look at number 3 from yesterday. That might remind you how it works. Okay. Now what? Oh, 33. Yeah, that's right. Okay. Find two numbers whose difference is 19. So, Sophia, what did it mean when it says the two numbers whose difference? What does difference mean? Like if I said, what's the difference between my age and your age? How would you find that? Yeah. So if it says the difference of two numbers, how could we write that? So the two numbers would be the two variables. So we can call them whatever we want to call them. I like A and B better than X and Y. So I would do the difference, subtract. So I would do A minus B is 19. And then the product, remember that one, Sophia? Product means, you guys remember? Multiply. So if we multiply them together, it's negative 84. It's been a while since we've done a problem quite like this. Any ideas? Actually, it's a little different than stuff. We've learned tricks to solve this, but it's been a while. Any guesses what we can do? Okay, this was chapter 7. Let me take you guys back in time a little bit. you guys remember solving problems like this? One way we solved it was it's called elimination. You add the two lines together, then like the y's go away, they get eliminated, or something like that. Sometimes we had to multiply one line.
Oh,
You guys remember that? Okay, the other way we solved this chapter was called substitution. Substitution is where you get x or y by itself, and then you can replace x or y with whatever x or y is equal to. So if x equals 10 plus 2y, we could change that x into 10 plus 2y. So on this one, we can't add the two lines together because these don't really add well, but we can use substitution. We add b, both these sides, we get a equals 19 plus b. I'll put it down here, I guess, or b plus 19. So what can I do with that? I can pick that up. If that's what a is equal to, I can replace a in the other equation. I get b plus 19 times b equals negative 84. Alright. By the way, chapter 7 will be on this semester test because that was like the first chapter we did. Yeah.
Would be equal -7.
Okay, so what can we do at this point? Well, can I just say negative 19 and 0 is the answer? No, because this is not equal to 0. So I need to use distributive property and bring these over, set it equal to 0. So if I multiply those by b, I get b squared plus 19b. And then how do I get this over to the other side? Plus 84. Alright, now it looks like one of the problems we've been doing. So we can use factoring or quadratic formula. You guys know something that goes into 84? 4 and 21, 7 and 12. Now, yeah, those both work, but which of those adds up to 19? 7 and 12. So if we use the factoring route, it's b plus 7 times b plus 12. So b could be what? Negative 7 or negative 12. However, there's two variables on this problem. There was an a and a b. So let me bring this guy down. This is one of our equations. It's kind of another trick from chapter 7. Once you get one of the answers, you plug it in to find what goes with it. If I plug in b is negative 7, I get negative 7 plus 19, which would be 12. So I'm going to write this as an order pair. Like if b is negative 7, a is 12. Or if b is negative 12, the other answer we got, negative 12 plus 19, a would be 7.
So, for all those the answers, you just need one or two bits.
What?
So, for all those the answer, it's like plus or minus.
Yeah, this is two answers, but each answer has an a and a b component in it. 12 and negative 7 is an answer. And negative 12 and 7. That was kind of a mess, wasn't it?
Will there be one of
Who knows, could be. I'll tell you Monday. Give you the final verdict. Alright, on 34, find two integers whose such that the first is 2 more than twice the second. Okay, do you guys remember what integers are? Sit forward.
Numbers. Numbers.
More specific?
Positive or negative.
Okay, yeah. Non-decimal, non-fraction numbers. Could be negative, could be positive. Usually it's kind of like the numbers on a number line. So no fractions or decimals. These are integers. So we have two variables again, find two integers. It says the first is 2 more than twice the second. So when it says the first, Hank, what do you think we should put in for that? A. Is, do you guys remember what is meant? Equals 2 more than
2 plus
twice the second number.
Two
Jesse.
Okay, yeah. If one number is A, the other number is B. Yeah. So one number is 2 more than twice the second number. That's what it would look like as an equation. And their product is 112. So Hank, what did we say product was?
Multiply.
Multiply. So if you multiply the two together, it's 12. Oh, 112. All right. What did I do last time on 33 at this point?
You did.
Well, I had to move stuff around, but this time it's A equal. So it's already ready to substitute for A. A equals all this stuff. So all of this stuff can go right there. By the way, this should go without saying. I know sometimes we have assignments that there's no work to show, like on numbers 1 through 3, can't show any work. But if there is stuff to work out and you don't show anything, I'm not giving you credit. Some of you might notice that by now. Some of you do it anyway, so you hadn't noticed, but most of you. You need to show work, especially on the evens, huh? If it's an assignment that's like multi-step and you're not showing work, I just assume you're not doing it at all. All right, I think I'm going to stop right there and let you guys try to keep going. Let's do 35. I think I'll let you guys skip 36. I don't want to explain it, so.
That's a good reason.
Okay, 35. The area of a rectangular piece of concrete is 120 feet squared. Okay, here's the rectangle. Do you guys remember how to find the area? We didn't do it this year, so I'm asking from like previous years. You guys know how to find the area of a rectangle? Yeah, you just multiply these two things together. Length times width, or sometimes they call it base times height. Yeah. Area, this is more like a geometry thing, but you know, sometimes there's crossover. Area is just measuring the size of a flat surface using square units. Like how many square inches could fit in here, that's the area. Or your house might be like 2,500 square feet. That gives you an idea of how much room is in your house. Anyway, that's area. And you get the area of a rectangle by doing length times width, base times height. Let's see, what was the other thing? The perimeter is 46. What's perimeter mean?
All the way around.
Yeah, it's the distance around. Like if you were walking around the edge, how far around would it be? So, how would we find the area of a rectangle? Let's call it length and width instead. If we knew this was, let's say, 10 or something, and this was 8, how would we find the perimeter? Yeah, you could do this plus this times 2. Because there's 2 of these, and there's 2 of these. So it'd be 10 plus 10 plus 8 plus 8. Okay. So the perimeter formula is like 2 lengths plus 2 widths. The area formula is just length times width. Alright, what was the perimeter on this one? 46. Okay, so these are kind of the 2 formulas we're going to use. So for the area, it's length times width should equal the area, 120. For the perimeter, it's 2 lengths plus 2 widths should equal the perimeter, which is 46. We probably should have done a worksheet with some of these word problems, but we're kind of out of time. Okay, now it's kind of like the last 2. What can we do at this point? Well, we can go for substitution. Again, I would solve for L or W here. How would I solve this for L? Subtract 2W. Get 2L equals 46 minus 2W. And then how would I get rid of this 2? Divide by 2. When you divide by 2, you'd have to divide all terms by 2. Okay, so L, which stands for length, is equal to 23 minus the width. So we can use that in the other equation and replace L with 23 minus the width. All right, so we can kind of clean this up a little bit. I can multiply those both by W, distributive property. This would be negative W squared plus 23W. And then what would I do?
Subtract 120 from both sides.
Subtract 120 with 1 0 over here. They don't mix because they're not like terms. Alright. Does that factor? What goes into 120? Yeah, it's 10 and 12, but it doesn't work. It surely factors. If your W squared is negative, it would be easy just to multiply both sides of this equation by -1 or divide by -1. That's going to switch all your signs. Let's see, what else goes into 120?
Wait, why did this 3, 4, 4, and 3?
Those are just, I don't
I
know.
multiplied by -1 because it makes, if you're factoring, you want this to be positive. It makes it a lot easier. Huh? Is my answer like one off? Did I copy the numbers down right? 46, 120. Oh, yeah, it works. Even if it didn't work, it would still work because we could use quadratic formula and be a decimal, but yeah, 8 and 15 do go into 120 and they do add up to -23, but it would be -8, -15. So the width could be 8 or the width could be 15. All right, it's taking too long. So one of our equations from the beginning was that the area is 120, so that length times width is 120. So if I know the width is 8, how would I find the length? Divide by 8. That would be 15. So it's either width is 8, length is 15, or if the length is 15, divide by 15, you get the width. Sorry. If the length was, no, that's what I wanted. If the width was 15, the length would be 8. So it's one of those two. 8 by 15, basically what it would be. Alright, yeah, those are hard, sorry. 37 says find f of -1. This is much easier. What does that mean though? What does f of -1 mean? Let's see. Jackson, do you remember? Up in the directions it says f of x equals x squared plus 5x minus 7. So what's f of -1? Okay, now this just means what's the f function worth if we replace the x with -1. So all it means is plug in -1. Okay, don't remember this assignment? It's like Monday, I think. Somewhere around there. 1 minus 5 is -4 minus 7. -1. And 38 is g of 3, so that'd be the other function. Oh gosh. Okay, 39, so we're on the next page. Says find p of 5. But they don't give us a function equation, they just give us a picture. Any guesses of what p of 5 will be? I'm guessing not.
What would this P stand for?
The function that they graphed on the right. Okay, this means what's the function value when you put 5 in for x? On the graph, the function value is like the y value. So if you go over to 5 on the graph, what's the value of the function at x equals 5? Right. If you go to 5 on that graph, you have to look in your book. It crosses, the graph like goes right here. At 5, it's the graph's down at -3. So when the function is at 5, or sorry, when x is at 5, the function's value is -3. Okay, 40. I'm guessing we forgot what this means too. What are the zeros of a function? This is Wednesday's assignment. That's right. It's the zeros of the function are what x values make the function equal 0. They're also what are the x-intercepts on this graph. So where is that graph crossing the x-axis? 2 and 4. That would be the answer. We didn't really, I talked about it graphically, but we didn't really do these problems with graphs. So anyway, this one's kind of a mess. 41, what's the maximum of the function? So the maximum is how high does the function go? Yeah, the maximum y value is 1. And yeah. Okay, there's kind of a second question. What's the x value that produces the maximum? And that would just be when x is 3. Okay, on 42, what's the equation of the line of symmetry? You guys remember what the line of symmetry was? Right, a line down the middle. So on this one, the middle is like right in here. So what's the equation of this line?
X equals 3.
X equals 3. Yeah, so it kind of looks like 41. How far did I say we're going? 48? Word. All right. All right, we got 4 graphs left. Okay, everybody get one? What? 6. We're only, oh, no, sorry, yeah, I only wanted to go to 46. I didn't want to put that. let's look at like the most complex example I can do, and then we'll go back and look at whatever they put. Okay, so when you have like a y equals x squared, it makes parabolas, right? What is this negative? What would that negative do to the parabola right there? You guys remember? Upside down. To go down. What does the 2 do to the parabola right there?
Makes it go down 2 times.
Makes it go down twice as fast. Like steeper is what we put. What does this plus 3 do to the graph? Moves it left 3, and that moves it down 4. Okay? Whatever's on the x moves it in the x direction, left or right. But it does the opposite. So this moves it left 3, this moves it up or down, this would be down 4. Alright. So like the vertex for this would be left 3, down 4, if they asked. I just made that up, that's not. So 43 is much more basic than that. It just says 1/2 x squared. Okay, so what's the vertex? 0, 0. I don't think we have time to find the zeros for all these, but basically 0, 0. What's that 1/2 gonna do to the graph? Yeah, make it go up slowly. So here's how we did it. I just had you put the vertex in there. And then what did I do after that? Yeah, I had you plug in a couple numbers close to the vertex. So if I plug in 1 squared is 1 times 1/2 is 1/2. If I plug in 2 squared is 4 times 1/2 is 2. So we got 0, 0, 1, 1/2, 2, 2. Alright, this is the vertex, this is the middle. So that means these points are reflected over to the other side. Okay, so on this one, okay, how about 44? What's the -6 gonna do on 44? Huh? Down 6. It's not in parentheses, so it's not left or right, it's just down 6. So the vertex would be where? 0, -6. Okay, on 45, what is this -2 gonna do to the graph? Right 2. So where's the vertex going to be if the graph moves right 2, 0. So I'm going to plug in 3 and 4. So if I put in 3, if x is 3, I get 1 squared is 1 times -3. If I plug in 4, 4 minus 2 is 2, squared is 4 times -3. Going down to -12. So our graph, we should put our x-axis way up here. So 2, 0, 3, -3. Barely squeezed it on there. 4, -12. like this. No, what did I do wrong?
It's backwards.
Well, okay, the first point I graphed was the vertex, right here. That's the middle of the graph. This is the middle. The graph is going down. So, anyway, these points reflect over here. Not my best drawing. Drawing.
What about the zeros?
We don't have time for that. That's what we did Wednesday when we just set the whole thing equal to 0 and solved it. Are you done? AJ, stop leaning back. Why don't you try an even? AJ,
What?
try an even.